Let's say we're asked to draw all of the structural isomers that have the molecular formula C5H12. The word isomer means same parts, and so we're talking about the same number of atoms. All of our structural isomers are going to have 5 carbons and 12 hydrogens. Our isomers are going to differ in how those atoms are connected to each other, so they differ in terms of their structure, and that's why we call them structural isomers. You can also call them constitutional isomers. So we need 5 carbons, so for our first isomer, we could just draw 5 carbons in a chain. So here are my 5 carbons in a chain. And you should have already seen the video on bond line structures before you watch this one. So let's draw out those 5 carbons, and let's double check and make sure we have the correct number of hydrogens. The carbon on the far left has 3 hydrogens, so here we have our 3 hydrogens. Next carbon has 2. Same with the next carbon, so 2 for this one. 2 for the next carbon, and finally 3 hydrogens for the last carbon. So let's count up everything and make sure we have the correct molecular formula. So we have 1, 2, 3, 4, 5 carbons, so that's C5. And then we should have 12 hydrogens. Here's 3, plus 2 gives us 5, plus 2 gives us 7, plus 2 gives us 9, and then we have 3 more for a total of 12. So C5H12 is the molecular formula for this compound. All right, let's draw another structural isomer that has the same molecular formula. So instead of drawing 5 carbons in a chain, now we have to draw 4. So let's start by drawing 4 carbons. We need a total of 5 carbons, so we need to show the 5th carbon branching off of our chain. So we could show the 5th carbon branching off of our chain here. So let's draw in those 5 carbons. So here we have our 5 carbons. Let's count up hydrogens. Carbon on the left has 3, so 3 hydrogens here. 3 hydrogens on this top carbon. There's only 1 hydrogen on this carbon, 2 hydrogens on this one, and finally 3 hydrogens on this carbon. So let's count up our atoms. So let's use red for this one. We have 1, 2, 3, 4, 5 carbons, so that's C5. And then for hydrogens, we have 3 here, plus 3 gives us 6, plus 1 gives us 7, plus 2 gives us 9, and 3 more for a total of 12. So C5H12 is the molecular formula for this compound. So these two drawings represent 2 different molecules. Both of these molecules have the molecular formula C5H12, but they differ in terms of how those atoms are connected. They differ in terms of their structure. So we call them structural isomers of each other. All right, to draw another structural isomer, some students might say, oh, well, we could start with 4 carbons in our chain again, and this time, instead of showing a branch off of this carbon, we could show a branch off of this carbon. And so a student might draw this structure and say, okay, there's a different structural isomer. But actually, these are just 2 different ways to represent the same molecule. If you analyze that second structure that we just drew, right, the connections are the same. We have a CH right here bonded to a CH3, bonded to a CH3, and bonded to a CH2. And the CH2 is bonded to a CH3. That's the same structure as what we drew out over here. So it looks like it's a different structure, right? It's a different drawing than the one up here, but actually this is just 2 different ways to represent the same molecule. All right, so we have 2 structural isomers so far. Let's think about 1 more. So we can no longer do 4 carbons in our chain, so we go down to 3 carbons. So we start with 3 carbons in our chain. We know we need a total of 5 carbons, so we need to show 2 more carbons added to our chain, and we would have to add those 2 carbons to our central carbon like that. Let's draw out all of our carbons here. And let's add in our hydrogens. So this carbon would have 3 hydrogens. Same with this carbon. And the same with this one. And finally, the same for this carbon. The carbon in the center, right, this carbon in the center here already has 4 bonds, so it doesn't have any hydrogens on it. Let's count up everything. Let's count our carbons first. 1, 2, 3, 4, 5 carbons, so C5. And then we have 3 hydrogens, plus 3 is 6, plus 3 is 9, plus 3 is 12. So C5H12 is the molecular formula for this compound, and this is another structural isomer, so it's a different molecule from the other two. So we have a total of 3 structural isomers that have the molecular formula C5H12.